of the summer, Mr. G Math. Woo! Live at room 7202, June 30th. Yay. My mom turns 80 today. Isn't that exciting? That's her. That's true. In Canada. So, the big 80. So, happy birthday, Mom. I'm sure you see these videos. Good job. All right, this is our last video for the summer. I don't make videos for vanity. Instead, I know that what you don't practice with the summer, you'll forget. And I don't expect you to do this every day, but before we come back together again on August 24th, and I'll see you that morning, that the day two or the weekend before, you can go over, right, what we did this summer so that we can hit the ground running, right, rather than starting from scratch again. So, here is really our first application of calculus, word problems and where it's applied. So, in related rate problems, you're going to have a story. The idea is to find a rate of change with respect to time. How is something changing with respect to time? Of one quantity by using the rate of change of a related quantity. So in this example, you'll have two rates at the same time that change over time. Two of them. Draw, and here are just some guidelines to help, and we'll practice these together. You don't have to do everything, but it's nice to have a start to figure it out. So when you have a related rate problem, draw a figure. That will be a geometric shape in this case. And choose variables for all the unknowns. Write what is given and what is to be found using the variables d by dt. You're not going to have that by dx part because it's not with respect to x but with respect to time. That's where that t is going to come in. It says write an equation relating the variables. If a quantity is changing over time, it must be a variable. But if a number is constant over time, so over time that number never changes, whatever it is, the height of a cylinder or something, it never changes over time, then you write what's constant just as a number rather than a variable. And again, we'll practice. It says look for secondary relationships between quantities to reduce the number of variables. Sometimes you start with an equation, you have lots of variables, and you have to be able to have a secondary relationship to do a substitution to bring down the number of variables. Implicitly differentiate both sides with respect to t, and then substitute number values and solve. So that's the basic guide of what we're doing. These problems are reading, they're story problems. So what are some geometric formulas you are expected to have memorized in calculus? Not given, but you have to know. Okay? Do you know for a right triangle how the sides relate to each other? Which theorem is that? Good. Do you know how to find the area of a triangle? Half the base times the height. Do you know how to find the area of a circle? And the circumference. Remember doing this when we were Math 3 at least for the Alex, right? In terms of stuff, right? This one isn't obvious, but you still got to know it. What's the volume of a sphere? 4/3 pi r cubed. Do you know the derivative of that is the area? If you take the derivative of the volume, it gives you area. What's the derivative of pi r squared? Whoa. What's the derivative of the volume? Whoa. What's the derivative? E is not in this example, E is not like the E that you think of as a number. E means edge. I don't know why they have the letter E. I would use the letter S to represent one side. So if you're confused with that letter E, because you think it represents 2.71 as an exponential, E, they meant edge, whatever, a side length, right? So what's the volume of a cube? You take one side length and what do you do with it? Cube it. Take the derivative, right? You get 3s squared, right? But we need to have like twice that for 6x squared for the area of each side, the surface area. What's a cone? 1/3 pi r squared. What's a rectangle? Think times width. What don't we have here that I want you to add? I don't know if I can spell it. Did I start it off wrong again? How do I just, huh? Linder, right? I do okay? What's the volume of a cylinder? It's similar to a cone without the 1/3 part to it. Pi r squared times h. So it's similar to a cone, but it's pi r squared times h. All right, let's look at some examples, and then on the next page is where you'll have some stories, and then it's practicing these stories, feeling comfortable with them. So in these problems, the first 3 steps of the procedure are already done. We just need to compute only the last 2 steps. So what's given is a equals s squared. What we want to do is take the derivative with respect to t. So the derivative of a with respect to t, s squared is 2s, but then the chain or the hook is the implicit part, is the derivative of s with respect to t. That's going to be the different feeling in your gut, right? Similar to y prime. Y prime means the same as dy by dx. But instead of going a prime, which you could do, it's just making it obvious that it's with respect to time, to know what to plug in. And there's no algebra here to manipulate. We're not trying to get something by itself like we do with y prime. All right. In the question, does it tell you what ds by dt equals? Right? So where you see an s, what number are you going to put in? 4. Where you see ds by dt, it is 3, and then you solve it. So the question, the answer was that what is dA by dt? And it's 8 times 3, which is 24. So in this scenario, it would seem to me that would be the area of a square. So how is the area of the square changing over time? So when we take the derivative, the side length is increasing. And why do I know it's increasing? Because it's positive. Now there's no unit here, but let's say the unit was inches or centimeters. What you're given is that the side length of a square is increasing by 3 centimeters per whatever the time unit is. How is area increasing as the side length is increasing? So there are 2 things happening at the same time. The side is increasing, but as the side increases, the area is connected to it, and it's increasing. And how is those 2 things related? So that's how it happens. So dA over dt, we just found it. The answer was 24. In these examples, you don't have units, but when we turn the page, you'll see units to do with measurement and time. Okay, let's try one more time, and then we're going to read that word problem on the next page. It says dx by dt equals -6, y equals 4, and xy equals 12, and it says find dy by dt. So we're going to start with the last equation. X times y equals 12. This is going to be a bit of a challenge because we have to do the chain rule, but in this scenario, when you take the derivative of x, it's not 1. Instead, it's going to be dx by dt, but we need to practice that. So first, what's the chain rule or the product rule? X times y. So it's what? The first, which is x. The derivative of y, we would normally write down y prime. In this example, y prime is not dy by dx, but dy by dt, because we're taking the derivative with respect to time. So the derivative of y, what am I going to put in? Dy by dt, plus the second, which is y. Now, when you take the derivative of x, the derivative of x is 1, but we need the chain dx by dt, because we're not taking the derivative with respect to x. If it was in respect to x, then it would just be 1. But it's with respect to t, so that's kind of like x prime, right? And x prime in this case is dx by dt. And then the derivative of 12 is 0. What's new in this problem is taking a derivative with respect to another variable. Do you get that? Nothing else is new. We're used to taking a derivative with respect to x, but we're not now. We're taking it with respect to time. That's the difference. That's what this dt is, okay? This is like the, right, this is implicit in that way, where the derivative of x is 1, but then you have to include the hook. The hook, in this case, is dx by dt.
So
that was the hard part. Go ahead.
if you're taking how do I say this? Like, if you're doing the equation in respect to like a different variable, x becomes dependent. That's what
Right, that's exactly right. In that you need the hook, that implicit hook connected to it.
Got it.
So, and it is going to take practice. The rules are all in place. It's just applying the rule differently. What number do I plug in for x? I don't know. I do know. You know how I know? Is what is y equal?
4.
So if I take the first equation, and where there's a y, I put in 4, what would x equal? Even though it's not given, you could solve for it. 3. So where there's an x, I'm going to plug in 3. dy by dt is my unknown. That's what I want to know. Y is which number? 4. dx by dt, which is saying, how is x changing over time? Is that x value increasing or decreasing? So in this sense, what's happening? It's decreasing, right? By what number? And that's a rate equal to 0. Can you get dy by dt by itself?
Yeah.
So 4 times negative 6 is negative 24. Add it to the other side. Divide it by 3. To interpret this, as x is decreasing, at the same time, what's happening to y? It's increasing by 8. Rates. Turn the page. Can I read you a story? Number 2. A windlass is used to tow a boat to a dock. I don't know what it is. Like when I hear lass, I think like Scotlander, right? Or something like laddie or lass. Like it's windy in Scotland, so they call it like a girl wind, so it's a windlass. I don't know. That's it, man. That's been recorded for all time. So, for our problem to really know what a windlass is, doesn't have great meaning to it. But whatever that object is, it's obviously some type of object, right? Whatever that object is, there's a rope attached to it, and it helps tow a boat. Yay. Okay, so the rope is attached to the boat at that point, 15 feet below the level of the windlass. If the windlass pulls in the rope, so this rope is getting shorter over time, right, as the boat comes in. So as the rope gets shorter, at a rate of what? 30 feet per minute. So do you see a rate and it's changing over time? At what rate is the boat approaching? Now the boat is approaching. What letter represents how close the boat is coming in? X. And the question is, what rate is it coming in at? The rope is going in at a certain rate. What rate is it going in at? So in other words, our unknown in this problem is going to be dx by dt. In other words, how is x changing over time, right? And we already have the sense that x better be, that rate better be negative. Why does it need to be negative? Because it's getting shorter over time, right? It's getting closer, or else it's going further away. I notice this 15. Do you see it? That 15 is constant through the whole problem. That's an important concept. What does that mean? That 15 is constant through the whole problem. So as the rope is being pulled in, the boat's getting closer, does that number 15 change over time? If something doesn't change over time, it is constant, right? Got the connection there? Okay, what information do I know and what I don't know? So let's see what we got. So first of all, it says the rope is being pulled at what rate? So that's dz by what? Because the length of the rope represents what letter? Z. The rate that it's changing over time then is dz by dt. We together? And if we're really together, we'd recognize the rate is negative. And there's a unit involved. So at what rate is that rope getting smaller? Negative 30 feet per minute. It's getting shorter and shorter as it's getting pulled in. Yes? And then it says, at what rate is the boat approaching the dock when there is 25 feet of rope out? That 25 represents what letter? Z. Now, what letter don't I know that I can still solve for? What equation would I use to solve for x? Good. That would be 15 squared plus x squared is equal to, we know what z is, right? So can you solve for x? Now we have the numbers we need to use after we take the derivative of an equation that we haven't come up with yet. But I need to know what x equals. So do I have enough information to know what, when the rope is 25 feet out, how far away is the boat from where it needs to be? How would you solve this? None of you have calculators, right? It's done. Can I tell you this? 25 squared is 200 and... Oh yeah, 600 and... 15 squared is 225. 25 squared is 625. So when I subtract, it's a nice easy number. That easy number would be 400. Is that easy to take the square root of? What number times itself equals 400? So when the rope is 25 feet out, the boat is how many feet out? 20. So I'm going to put a box around the numbers we need. We need that. X equals 20. We need to know z is 25. And we need to know the rate, right, that it's going out at, which is negative 30. All right. This is all preview stuff, right? Prepping it so that we can do the work. Now we need an equation that represents the whole situation. So we're going to go back to our friend again. When you have a right triangle, what's the relationship between all three sides? The Pythagorean, right? So what is the Pythagorean in this case? Recognize we don't need a letter for this side because 15 never changes. So we can write down 15 squared plus what letter? X squared equals what? That is my equation, my anchor equation, where I'm now going to take the derivative of. Notice I didn't even care what 15 squared is, because what's the derivative of 15t squared? 15 squared. 0, right? Any constant. What's the derivative of x squared? And what do I have to include? What's the hook, the implicit part that I need to have? dx by dt. What's the derivative of z squared? 2z. What needs to be included? The hook, that implicit part. dz by dt. Now, my goal is to find what? This is my goal. So, I don't have a number to plug in for it. Do I have a number to plug in for x?
Yes.
What number? 20. dx by dt is my unknown I'm solving for. The number for z is 25. dz by dt? Negative 30. Now, it's just basic algebra. Can you get dx by dt by itself? I'm not even going to multiply it out. Do you know why? Because, well, ultimately, it doesn't matter, but I'm still going to simplify it. If I didn't have a calculator, why is it helpful to not multiply it out? So notice 2 times 25 times negative 30, in that what is being divided by? 2 times 20. What happens to the 2's? They divide out. How about 20 and negative 30? What does it become? Negative 3 and 2. Now is it easier? 25 times negative 3 is 3/4. What's half of 75? And is the rate negative? So at what rate is the boat being pulled in at? And the boat is being pulled at that rate, 37.5 feet per minute, exactly when the rope is 25 feet out. That's called a related rate. What were the two rates that relate to each other? The rope and the boat. Two things, right, at the same time relate to each other, both with respect to time. All right, number 3. That's an awful picture. But its gravel is falling on a conical pile. What does that mean, conical? It almost sounds like it's comical. Huh? Huh? What geometric shape is a conical pile? A cone. Right? Put ice cream in. At what rate? 10 feet cubed per minute. Why is it feet cubed per minute? Volume, right? Because you're filling up a cone. It's volume. At all times, the radius of the cone is twice the height of the cone. I'm just going to read the whole thing, and then we're going to break it down one sentence at a time and do some pre-work before we do the real work. Find the rate of change of the height of the pile when the radius of the pile is 6 feet, and then write a sentence explaining the meaning of your answer. So let's break it down one sentence at a time. Gravel is falling on a conical pile at what rate? That means the volume is changing with respect to time at what rate? Does that mean that volume is increasing or decreasing over time? Does that make sense as gravel is being poured on it? Yes. That's just one sentence, right? Can we break it down? Next sentence. At all times, what do we know about the radius? The radius is twice the height. That's it. So we know that R represents the radius, H represents the height, V represents the volume. Find the rate of change of the height of the pile. So what are we trying to find ultimately? What's my end goal? The rate the height is changing over time. How do I describe that with calculus? dH by dt, right? How the height is changing over time. So that, I can put a little question mark. That's my goal, right, at the end? Next sentence, or next part. When the radius is what? So I write down the radius. It's all pre-work, right, on the side. And then it says, write a sentence explaining the meaning of this answer. So right away, my gut says, if the radius is 6, could you tell me the height right away? What must the height be? Because the radius is twice the height. Or if you plugged in 6 for R, you could divide by 2, right? Going the other way and get that answer. And it's 3 what? Feet. What equation would describe this whole scenario? What geometric equation? What shape do we have? Cone. What are we talking about the cone? The what of the cone? Volume. What equation tells me the volume of a cone? 1/3 pi r squared times h. You could also go pi r squared h divided by 3 at the end. Means the same thing. Okay. How many variables do you have on the right side? How many variables are changing over time on the right side? Do you notice that volume is changing, radius is changing, height? That is too many. Do you see that? I just want one variable on the right and another variable on the left. I don't need an extra one. Is there anything here that can help me get rid of a variable?
Yes.
Now, do I want to keep r in the equation or h? Because I'm going to get rid of one of them. What's my goal? So I want to keep which variable? So where there's an r, adios, what goes in its place? Because I want to get rid of it. What does r equal? 2h, right? Now we have an equation where we don't have multiple letters, right? We have that one variable now. We have volume and height only. We don't have radius and height and volume. Why can I not plug in 6 yet? Because I have to take the derivative first. Then I plug in. The only time you would plug in a number, now, at the beginning, if that number is constant over time. Does that number change over time? Then you have to take the derivative first. Is it constant over time? Then you plug it in right away. Yes? Okay, can we do some algebra here before I take the derivative? What's 2 times h squared? 4h squared. And I'm going to put the constants in front. So that is 4h squared times h. 4 is going to go in front. And 4 times 1/3, because I can multiply in any order, is what? And pi is also a constant, right? Those are the coefficients. So 2 squared is 4, and 4 times 1/3 is 4/3, and there's also a pi there. What exponent is on the h when I multiply that? H squared times h, add the exponents, and what is it? This is what I'm going to take the derivative of. 4/3 pi h cubed. It's now simplified. You did algebra first to make the calculus easier. Now you're going to take the derivative with respect to what? Time. What's the derivative of v with respect to time? dv by dt. Just v is 1, but you need the hook. You need that implicit part. How do I take? This is just a constant in front, by the way. Do you notice that? It could say 2h cubed. Don't matter. So what do I do with the exponent? What is 3 times that garbage in front, right? What happens to the 3's? They divide out. What are you left with? That's it, right? And then what do you do with the exponent? Subtract 1 and it's down to 2. And what's the hook you have to include? The rate, dh by dt. What's my goal again? dh by dt. That means every other variable, there has to be a number, right, that plugs in. What number gets plugged in for dv by dt? 10. 4 and pi are numbers already. What number gets plugged in for the height? And then what's my goal? dh by dt. All you have to do is get dh by dt by itself. I don't care if you simplify it too much. 3 squared is 9 times 4. So this is 10 divided by what? 36 pi. Let it go. And what's the unit that height is changing over time? What's the rate? What's the unit? The height is changing by that many feet per minute. Why is it not feet cubed? Because height doesn't describe volume, just the height. And you could reduce it down to 5 or 18 pi and so on. What's a sentence that you could write down that would describe what's happening? Can we write down the sentence together? I'm going to do that on this piece of paper. What sentence would you write down to answer the question? Right. So, can we start here? The height of the pile is changing. Right. How is it changing? Increasing or decreasing? So the height of the pile is increasing. At what rate? Of 10 over 36 pi feet per minute, right? When what? When the radius is it's not a complicated sentence, but it's directly including everything you need to include. Do you see that? The height of the pile is increasing at a rate of that in feet per minute when the radius is 6 feet. There is a skill to writing a simple sentence, but includes all the info you need in that sentence. Okay? It's not an essay, but one sentence has to include all the parts you need. That's it. Over and out. Last video.